Good morning and welcome to Chapter 9. Today we're starting a new chapter in Algebra 1, and 9.1 is graphing quadratic equations. If you're following along with your notes, I want to take you to like the second or third page, typed page that looks like what you see on the screen in front of you. And I just want to bring out a few highlights here because I think this is important. So, first of all, the graph of a quadratic equation is called a parabola. Everyone say parabola. Parabola. It is not a parabola. Please do not call it a parabola. It is a parabola. Parabola. It is a U-shaped curve. It's U because they named it after me, Mrs. Urso. So it's a U-shaped curve. The vertex, that's just a joke. The vertex is the minimum, which would be the lowest point on the graph, or the maximum, which is the highest point on the graph of the parabola. So again, the graph of a quadratic equation is called a parabola. The shape of it is a U-shaped curve. A is the coefficient or the number in front of the x squared term. So if you look at the top, I've given you the general form of a quadratic equation. We spent lots of time graphing them back in Chapter 8. Y equals ax squared plus bx plus c. So the greatest exponent in a quadratic equation is the exponent of 2. The number, or a, in front of the x squared term is really important because if a is positive, the graph opens up like a cup. If a is negative, the graph opens upside down like a frown. And you'll see this in a few minutes. What method do we use for graphing? Well, in Algebra 1, we make a table. We pick points for x. We generally use 0, 1, 2, -1, and -2. It's a very good place to start. We're also going to talk about the axis of symmetry. And the axis of symmetry is what we call the fold line of the parabola. The equation for the axis of symmetry is x equals -b over 2a. And all parabolas exhibit the property of symmetry. So I would like to go on record as saying this. Probably from this one sheet here, I could come up with a 10-question quiz like that. Did everyone catch that hint? Now, obviously, tomorrow we have a test, yes? But this is all free game because I'm not asking you to graph anything. I'm not asking you to find the axis of symmetry. But everything that's on there, you're responsible for, and you can have a quiz anytime after tomorrow. You with me? Okay, so this is an extremely important page. I would make sure you know all the definitions. You can make flashcards or do whatever you need. God bless you. And bless you again. The domain and the range. Well, we know that the domain is the x value. If the graph opens up, A is positive, the graph is going to look like the letter U. The domain would be all real numbers, and the range would be greater than or equal to the y value of the vertex. If the graph opens upside down, A is negative, so it's an upside down U. That's why it says down like a frown. The domain again is all real numbers, and the range is numbers less than or equal to the y value of the vertex. Was that not in your notes? Okay, then go ahead and add that in. So people who are following online, you might want to add that in. Okay? I thought I had it on mine. Sorry. So we're giving you a minute to just fill something in. Alrighty? And then I'll get right into it. We'll graph a couple of these and we'll see how far we get. I did make it warmer. I hope it feels better. No? Are you guys still cold?
It's better.
Okay. We can adjust. Alrighty. Y'all with me? Again, let's just review. If you know the answer, raise your hand. The graph of a quadratic equation is called a blank. Raise your hand if you know. Come on, real quick, without looking. Jenny. It's called a parabola. It is a blank-shaped curve. What letter does it look like?
Yeah.
Good. If A is positive, which way is the graph opening? Yes. Up. If A is negative, which way is the graph opening? John?
Down.
Down. Good. What's the best way to graph a quadratic equation? What do we do? What's the technique?
Make a table with 0, 1, 2, -1 to -2.
Good job. Good job. The blank is called the minimum or the maximum point of the parabola. Raise your hand. Thank you. Go. The vertex. Good. So you just see how I got those. What's the equation for the axis of symmetry? What's the equation for the axis of symmetry?
Negative b/2a.
Okay. Whole equation would be x equals negative b over 2a. Make sure you give me x equals negative b over 2a or it is an incorrect answer. Okay, I'm going to move on, but I'll come back to this. So let's go ahead and get started today in our lesson. And we're going to pick it up with probably the most important, or what I like to call the parent graph of the whole thing. And this is actually probably not going to be in your notes, but that's okay. Again, one more time. Graphing quadratic equations. Parabolas have a geometric property, so all quadratic equations or all parabolas exhibit the property called symmetry. That means if we were to fold it in half, it's going to match on each side. Okay? It's going to match on each side. So let's just go ahead and take a nice, easy problem for you. One more time. Y equals ax squared plus bx plus c is the quadratic equation or function where a cannot equal 0. Obviously, if a was equal to 0, we don't have a quadratic equation. We're dealing with a linear equation. And then I gave you a thumbs up and a thumbs down. I gave you the U-shaped curve. It's up if a is positive, and it's upside down like a frown if a is negative. So our parent graph here is y equals x squared, and everything else is going to work around this. Since a is positive, I want you to already know in your mind that your graph is opening which way, guys? Up or down? Up. Now you're going to pick your points and make your table. So let's go ahead and look at the points that I've picked. Again, we picked 0, 1, 2, -1, -2. Obviously, you are allowed to use a calculator for this. You are allowed to use a calculator for this. So we're going to go ahead and we're going to plug in and we're going to see what we get. Okay, so when you plug in 0, 0 squared gives you 0. When you plug in 1, 1 squared gives you. When you plug in 2, 2 squared gives you. When you plug in -1, -1 squared gives you. When you plug in -2, -2 squared gives you. Please don't ever tell me that -2 squared is -4. It's not. Okay? Make sure you put it in parentheses. All right, now we're going to go ahead and graph our points. So we graph 0, 0. We graph 1, 1, 2, 4, -1, 1, and -2, 4. So if I were to actually graph that for you, if I were to graph, can I borrow a pen, please? Thank you. Sorry. So if I were to graph a parabola for you, I want to show you what the symmetry would look like. What the symmetry would look like. Another name for the axis of symmetry would be called the fold line of the parabola, which means that everything on either side is going to be equidistant from each other. Let's see if I can get it to work. It's pretty close. So here's my parabola, okay? And right now, this is the lowest point of my parabola. It's the minimum point, and it is called the vertex. Obviously, the equation here would be A has to be positive or negative. What would you say? Tell me. Positive, because my graph is opening up like a cup, correct? So this fold line is the axis of symmetry. For those of you that are listening online, I'm just using a piece of paper that I folded, and I apologize that you can't see this, but please stay with me as I go over the definitions again, because they are extremely, extremely important. So if I were to ask you, what do you know that God has created that exhibits the property of symmetry? Please don't call out, raise your hand, and I'll be happy to call on you. Something that you know. An egg? How does an egg exhibit symmetry?
Because it's shaped like...
Okay, let's try again.
Like a heart.
A heart?
Like drawn out.
When you draw a heart. Okay, let's think of something that God created, a creature, something that flies.
Like a butterfly.
A butterfly. A butterfly exhibits symmetry. How many of you were here in JK? Remember making the butterfly wings and you had to put the same pattern on each side, symmetrical. Okay, so what happens now if this is my graph that you see in front of you? What would this tell you? Is a positive or negative, class?
Negative.
Negative, because the graph's opening which way? Down like a frown. Good job. So the axis of symmetry is the fold line. So here we have our points. We've graphed it. When I ask you for the domain, remember that the domain is all real numbers. So the x values could be anything. The sky is the limit. The range, when the graph is opening up like a cup, when A is positive, the range would be greater than or equal to the y value of the vertex. What was the vertex? 0, 0. So it would be greater than or equal to 0. Is that clear? Yes? All right. Now let's just show you, since we showed you what it looks like y equals x squared, let's show you what y equals negative x squared would look like. So we're going to pick our points again, 0, 1, 2, negative 1, negative 2. We put a negative sign in front. We put each number that we're plugging in parentheses, and we square it. We get 0. We get negative what? Negative 1. We get negative 4. We get negative 1 and negative 4. So when we go to graph these points, here's 0, 0. Here's 1, negative 1. Here's negative 1, negative 1. 2, negative 4. Negative 2, negative 4. This time, the vertex is said to be at a maximum because the vertex is the highest point on the graph. What would my domain values be here? What would my domain values be here? Yes.
0, 1, 2, negative 1, and negative 2.
How about all real numbers? All real numbers. Any number. Those are the numbers we picked, but all real numbers are possibilities. What would my range be? What would my range be? Anybody else want to give it a try? Go ahead.
All numbers less than or equal to the domain.
Y is less than or equal to 0. So let's go back and look just so you guys have this right. Sorry. Let me go back to the notes. Right here. One more time. The domain and the range. If the graph opens up, meaning that A is positive, the domain is all real numbers, the range is greater than or equal to the y value of the vertex. So if my y value on my vertex is 0, then it would be greater than or equal to 0. In this particular case of what we just graphed, A was negative, the graph opened upside down like a frown. Again, the domain will always be all real numbers, but when the graph opens upside down, the range is less than or equal to the y value of the vertex. So the range is less than or equal to, in this particular example that we just graphed, less than or equal to what? Less than or equal to 0. Does anybody have a question? So we've learned a lot so far. We learned what the name of a quadratic equation is called, what the graph is called, what shape it is. It looks like the letter U. You're going to have to be really careful when you graph these because you're going to be tempted to make them a V. That's an absolute value graph. That is not a parabola. Okay? Does anybody have a question up to this point? I want to take it to the next concept, which would be, how do you find the axis of symmetry? One more time, the axis of symmetry is the fold line of the parabola. On the actual graph that you're going to graph, you can show or depict the axis of symmetry with a dotted line. The equation to find the axis of symmetry is x equals negative b over 2a. And so I just want to give you a real easy way on how to determine what a, b, and c are. In the equation, y equals 2x squared plus 4x plus 1. I've just written completely underneath it the standard form of a quadratic equation, which is y equals ax squared plus bx plus c. And then I've just circled my coefficients, and that tells me what a, b, and c is. That's probably the easiest way I can explain it. So a is equal to 2, b is equal to 4 because it's the coefficient of the x term, and c is equal to 1. Now, if b or c are not there, then they are equal to 0. Okay, if there is no b term and no c term, then you would plug in a 0 for them when finding the axis of symmetry. So if I asked us to find the axis of symmetry for the equation y equals 2x squared plus 4x plus 1, step number 1, we've identified a, b, and c. I've written my equation, x equals negative b over 2a. Now I'm ready to plug it in. X equals a negative 4. The negative is part of the formula, guys, over 2 times a, which is 2. My axis of symmetry is x equals negative 1. Is everyone with me? Does anyone have a question on how I just found the axis of symmetry? I will tell you that when I reteach this again on Monday, it's going to just be so much easier for you. This is a lot of new information at one time, but it's okay. We're going to do a reteach and then tie it all together. Yes? It's the equation to find the axis of symmetry. It's given. I discussed that earlier. Okay, so that's a given formula. So we have the axis of symmetry. Now we want to find the vertex. So here are your steps to find the vertex. You're going to take the value of x from the axis of symmetry and plug it into the equation. Solve for y. The ordered pair made up of x and y is your vertex. So let's give it a shot. We just found that the axis of symmetry was what, guys? Okay, so we're going to say y equals 2 times a negative 1 squared plus 4 times negative 1 plus 1. All right, somebody tell me what you get. What does y equal? Y equals negative 1. So my ordered pair, or my vertex, is made up of the x from the axis of symmetry and the y we just found. So what would my vertex then be, guys? Outstanding. Negative 1, negative 1. So, how do you graph this? So glad you asked. To graph it, the first thing I'm going to do is I'm going to graph my axis of symmetry, which is x equals negative 1, and I make a dotted line. Then I'm going to go ahead and realize that my equation, let's go back real quick and look at the equation. The equation has y equals 2x squared plus 4x plus 1, so I already know the graph is opening up like a cup. We just found the vertex at negative 1, negative 1. Is the vertex at a minimum or a maximum? Well, if the graph is opening up, it must be at a minimum. And before we even finish graphing it, what would the domain be? all real numbers. And what would the range be? Not 0. Y is less than or equal to -1. Not 0, it's the vertex. -1. Let's go back to that page because we keep missing it. So let's go back here. Sorry. One more time. It's greater than, I'm so sorry. Y is greater than or equal to -1. Why is it -1 and not 0, guys? The vertex is -1. So let's correct that. I apologize. Let's find it. Sweet Jesus. There we go. So let's change that to a greater than or equal to. My suggestion to you would just be this. If you learn what it is for when A is positive, then when A is negative, it's just the opposite. It's as simple as that. So we go ahead and we graph. We draw the dotted line at the axis of symmetry, which is x equals -1. And we go ahead and we plot our vertex. But Ms. Urso, we have a little problem because those are the only points we have. Okay, so now instead of you having to take and make a table, because I'm going to warn you, this is a warning, listen, that sometimes when you're making a table, your graph is going to just keep going like in one direction. You're only going to get one side of the U, which means in order for it to swing around, you're going to have to pick another number far, far away on the opposite side. But this really helps by plotting the axis of symmetry. Come on, guys, stay awake, stay with me. And the vertex. Now what you can do is pick a number that does not fall on the axis of symmetry. So what I usually tell my students is this. Pick a number to the right of -1. Let's pick 0. And when you plug 0 in, y equals 2 times 0 squared plus 4 times 0 plus 1, you get 1. Then I pick a number to the left of -1, which would be -2. And when you plug that in, you get you get 1. Y equals 1. So now you have enough points. You have 3 points. You've got the vertex. You've got 2 points. You can see that that curve is coming around, and you have graphed your parabola. Okay, I'm going to give you guys one to try. So I want everybody to go ahead and let's go right in your study guide if you're following along with me. So everybody is going to go ahead and do number 1. Do number 1. All I need you to do is this. Graph it and state the domain and the range. This is what it looks like. Okay? Thank you for listening. We are going to pick this up next week as we conclude this lesson and add on our next lesson, which is looking at a graph and determining the number of roots. Have a great day, guys.